Now we're going to talk about the adrenal gland. So the adrenal gland is like a hat for the kidneys. So you can also call it the um, kind of associated with the kidneys, and they kind of just sit. So it can be suprarenal gland is also a term that you can hear from it. So you have the kidney, kind of looks like that, and then the adrenal glands are little hats. So they are two of them, one for each kidney. Both kidneys need a hat. And we have two regions within the adrenal glands. So we have the adrenal cortex, which is the outer layer. And the cortex actually has three layers itself. So in the outer part of the adrenal gland, you have three layers of the cortex that are going to have different hormones that are going to be released, different types and classifications. We're going to talk about the classifications and one type, but not everything. And then the adrenal medulla is the inner version, and it has the association with the nervous system because remember the hypothalamus comes down and has a connection with it. So this is going to be where your epinephrine and your norepinephrine are released from, is in the medulla. So sympathetic nervous system is going to be epinephrine and norepinephrine. Remember, they can act as neurotransmitters, or they can act as hormones. So the adrenal cortex is going to release corticosteroids. So these are going to be steroidal hormones that are released by the cortex. So that's why they're called corticosteroids. So they, again, are responding to ACTH, so adrenocorticotropic hormone. These steroid hormones are not stored in cells. So again, they're going to be intracellular. So they need to be consistently made and released. So they're released as they're made. So the corticosteroids don't stay in the cortex as they're made, they go out into the bloodstream. So each layer of cortical cells, or in the cortex, is going to produce a different corticosteroid. So you have our three different layers. So this is looking at the medulla is in the inner part right here, which is different. And then we have our three layers. The largest layer is called the zona fasciculata. And then we have the zona glomerulosa, which is the outermost layer. And then we have the middle layer, which is zona fasciculata. And then we have the zona reticularis, which is the most inner layer of the cortex next to the medulla, which is the middle layer. So first, going layer to layer, the first outer layer, the top layer, most superficial, is going to be zona glomerulosa. The glomerulosa is going to secrete a corticosteroid, but it's called the mineralocorticoids. So you can break down, so it's still a corticosteroid, and that's the corticoids part, but the minerals. So it's going to impact electrolyte concentrations. Mainly, we're going to focus on sodium. But sodium and potassium, major factors in the nervous system, muscular contraction. So the zona glomerulosa, the mineralocorticoids, are going to regulate minerals in your extracellular fluid. Of the mineralocorticoids, most famous of them all is called aldosterone. That's the hormone that's going to be released by the granulosa layer. So it's a mineralocorticoid. So is the general category is a mineralocorticoid. Aldosterone is one of them. Aldosterone is going to increase or stimulate the sodium reabsorption by the kidneys. So again, the kidneys, what happens and why we say reabsorption is, we'll learn more about it in the kidneys, is what happens is everything besides proteins and cells in the blood are going to be pushed into the kidneys. So they're going to be pushed out into the kidneys. And so they're filtered and then they're taken back. So it's reabsorption because we had it, we pushed it out, and we're taking back in. So that's the reabsorption. Now you see, okay, well, if you're stimulating sodium reabsorption, why am I saying increasing in blood volume and increasing in blood pressure? Sodium is kind of the one that's reabsorbed. Water hearts sodium. Wherever sodium goes, wherever salt goes, water's going to follow. That song, Wherever You Go, I Will Follow, that's water and sodium. So water's going to follow sodium no matter what. So what happens is with aldosterone, you're reabsorbing sodium and keeping it inside the body. Well, that means water's going to follow it. It's going to chase after it. By increasing your sodium level or your salt level, then you're going to increase your water level, which is going to increase your blood volume. So again, if you have larger amount of blood in the blood vessels, there's more pressure on the vessel walls, so you're going to increase blood pressure just by keeping sodium. And you can think of it, if you all of a sudden eat Chinese food, which has tons of salt in it, or a very salty meal, and then the next day you feel bloated and kind of waterlogged, it's because of this. Water's going to always follow the salt that you had. Because you're keeping a positive and you're keeping sodium, sodium and potassium always pretty much oppose themselves. Wherever sodium goes, potassium goes in the opposite direction. So potassium is actually going to be released by the kidneys. Aldosterone is released oftentimes when you have low blood pressure. Well, water's going to follow sodium. And oftentimes this is caused by what we call the renin, angiotensin, aldosterone. It can be the ROS system. So it's ROS. What happens is the kidneys are super sensitive to low blood pressure. They hate it. They don't like it. They want to change it. So if there's consistent low blood pressure, the kidneys are going to release renin. Renin is then going to cause the release of angiotensin, and then it's going to convert to angiotensin 2. We're not going to go into that much detail, which is then going to cause the release of aldosterone. And then aldosterone is going to have its effect. So the kidneys actually start the impact of the low blood pressure. It's going to recognize it, and it's going to try to fix it. So the next layer of the adrenal cortex is going to be called the zona fasciculata. And that's the biggest region in the middle. So it's the middle region. This secretes what we call, so we've gone through mineralocorticoids, and now we're at glucocorticoids. Still in the cortex, still a steroid, but this is going to have to be due to more glucose. So we've gone from minerals to glucose. The major glucocorticoids that we talk about are corticosteroid. So if you've ever given yourself a steroid cream, which is corticosteroid, that's going to be like hydrocortisone. And cortisol is going to be a major one. Cortisol, again, is response to adrenocorticotropin hormone from the anterior pituitary. So If you need levels of cortisol to be increased, you're going to increase your ACTH. If cortisol levels are high, then your ACTH, it's not, it's ACTH, should go back down. So if it's high, then it's trying to release cortisol. If there's too much cortisol, then it's going to be low. So negative feedback. Cortisol, along with other things, we talked about growth hormone doing this, and we're going to talk about glucagon doing it as well. But cortisol is going to be increasing your energy levels. So all of these things, amino acids are your last choice in the chain, but glucose, what do you use it for? ATP. Fatty acids, turn them into glucose, ATP. Amino acids, turn them into glucose, ATP. So it's all going to be blood levels of this so that you can use them to make energy. So when you convert fatty acids or amino acids, we call it gluconeogenesis. Genesis means make. Neo means new. So make new glucose. So you're actually going to transform fats or fatty acids and proteins, breaking down to amino acids. You're going to convert them into glucose. Again, make ATP. Cortisol wants to maintain high levels of glucose in your bloodstream. So you don't want your muscles to hog it all. So you're actually going to stop your muscles from being able to take it in. Your fat tissue loves to store. So you can actually make glucose into fat. So you can actually go the opposite way, glucose to fat, to store it in adipose tissue. Well, you don't want to store it. So you're going to inhibit the uptake in adipose tissue as well. One of the major things cortisol is doing, so you're going to actually increase your blood levels of glucose. So this is why it's going to also be highest in the morning, because all of a sudden you haven't eaten in a while. But you need energy to start moving your muscles, start getting up, start doing all the things that you need to do for the day. So cortisol levels are going to be higher. And you've also gone from sleeping, relaxing, chilling, to all of a sudden you need to get up and you need your blood pressure to increase. So you're actually going to cause vasoconstriction. Remember, it's going from diameter blood vessel to a smaller diameter. When you are going from larger diameter to smaller diameter, you're increasing blood pressure. Because again, blood's not hitting as much of the side versus all of a sudden it's hitting a lot of the side of the vessel when you decrease its size. So you're going to increase blood pressure. And it's going to help with blood flow to all your organs to get you going. If you have too much of cortisol, so you have too high levels, this is actually going to inhibit cartilage formation and actually storing calcium and making bone. A major thing is it's anti-inflammatory. So all of the positive effects that we talked about with inflammation in part of your immune system, it's going to suppress. And sometimes if you have too much, so for whatever reason your immune system is going a little too nutty, then you can use it to decrease it. So this is when I talked about hydrocortisone cream. You're itchy, all of a sudden there's a lot of inflammation. Well, you can use it as an anti-inflammatory. But when it's around consistently of high levels of cortisol, it's going to depress your immune system, stop your inflammation. So what is going to happen? You are going to get sick. And you are going to get sick a lot. So whenever you hear if you're stressed, and cortisol is actually considered a stress hormone in excess, we're going to talk about stress coming up, then you get sick more. Well, it's actually true. Having too much cortisol around is depressing your immune system. Depressed immune system, you can't fight off the bugs. It can also mess with your cardiovascular kind of system if you're always vasoconstricting and having high blood pressure. Not good for your heart and your blood vessels. It can have an impact on your nervous system and even can have an impact on gastrointestinal function. So it can actually even cause ulcers. So it's kind of disturbing the linings is one of the points. So if you have, say, stress can cause an ulcer, also another thing, because stress, increased cortisol levels can cause ulcers. Zona fasciculata is wrong. This is now talking about zona reticularis. So this is the inner layer. Is going to be the innermost layer next to the adrenal medulla. This is also some mineralocorticoids, is a little different, but this is going to be stimulated by ACTH as well. And we say that it secretes actually a small level of androgens or sex hormones. So it's actually adrenal sex hormones that are going to be in this. So they're actually weak androgens, and they are released and actually made into testosterone by the cells, and some can be made into estrogen. And remember, males and females do. So females mainly have estrogen, but they do have testosterone. And males mainly have testosterone, but they do have estrogen. So it's not always just one or the other. It's just a majority versus kind of between the two. So adrenal sex hormones, we're not exactly sure every kind of aspect of it, but we do say that it can help contribute to onset of puberty and secondary sex characteristics. So looking like a male or looking like a female, secondary sex characteristics. We can also see early hair growth in the armpits or axillary region, as well as pubic hair. In females, we know it increases or contributes to libido. And once the ovaries are no longer producing follicles and producing estrogen because they run out of eggs, then it's actually the source of estrogen after menopause. Now we're looking at the medulla, which I mentioned a couple of times already. So it's making catecholamines, and the ones that we're talking about is epinephrine and norepinephrine. Again, this is going to be your sympathetic nervous system. Fight or flight. So it's your nervous system where you're either going to hit someone or you're going to run faster than them. What happens when you have a catecholamine release? So think of the sympathetic nervous system, the fight or flight. Well, just like with cortisol, you're going to vasoconstrict. Why? You want to increase your blood pressure. You want to increase blood flow to certain areas. So you want to increase blood flow to your muscles. You're going to start breathing faster. You're going to increase your cardiac output by increasing your heart rate. You're going to increase blood flow that way as well. You're going to get it all going to your muscles. Your heart's going to be ready to move. You're not going to worry about your GI tract or your kidneys. You're going to worry about something that you either need to run or fight, hit someone, or run. You're also going to increase blood glucose levels. So this is another instance where you're going to increase your blood glucose. So you're going to have more glucose circulating in your bloodstream. So we saw this with growth hormone. We saw this with cortisol. We saw this kind of now in epinephrine and norepinephrine. Glycogen breakdown. Remember, glycogen in your skeletal muscle and your liver is your glucose storage molecule. So this is where you're going to increase your blood glucose levels because it's not going to be going inside the all of the cells. It's going to go in certain ones. And you're going to increase because you're going to break down your store and release it into the bloodstream. But imagine what you're going to do. So all of a sudden you're getting ready to use your muscles a heck of a lot. You're going to use your muscles if you're hitting someone. You're going to lose your muscles if you're running like the wind. What do your muscles need? A lot of ATP. How do you make ATP? At least partially, not only oxygen, which is why you're going to increase your blood flow everywhere, but you're going to increase your glucose. You need glucose and oxygen to make ATP. So this increased blood glucose levels because you are getting ready to use your muscles a lot and you need a lot of ATP molecules. Blood is going to go to the heart, increase cardiac output, skeletal muscle, that's what you're going to use to hit or run. And then your brain, because you're super focused. Epinephrine and norepinephrine make you really focus. That's why kind of stress and all of a sudden short-term stress can kind of really make you focus on something and think clearly is because of the norepinephrine and epinephrine. So pineal gland is going to be just a little side note. It's a small gland that you've seen in the brain when we went over in anatomy. So it's hanging off the roof of the third ventricle, that little lake, one of the lakes inside the brain. And that is going to be a major point of neuroglial cells, so not neurons, but the supporting actors, and pinealocytes. What does the pineal gland do? Melatonin. And also, so melatonin is actually kind of derived from serotonin. So the tonins. What does melatonin have an effect on? Well, the brain. So it actually has an effect on your biological clock, meaning it's kind of the timing of reproduction. It can also have an effect not only as the androgens from the adrenal glands, but effect on puberty and sexual maturation. So timing of reproduction, being prepared for reproduction is the pineal gland. But kind of everything that happens day to day is your day and night cycles. So this is why you get sleepy. And most people, you sleep at night and you're awake during the day. So more melatonin is released at night because you're supposed to be sleeping, and less than during the day because you're supposed to be awake. So that's why you see melatonin in various milligrams in pharmacies and the grocery store, is if people are having trouble sleeping, they supplement with melatonin. And that's natural, have an effect on your brain to cause you to go to sleep. So lastly, we're going to kind of go back to cortisol and epinephrine, kind of make a loop. So stress is either a physical or emotional condition that's going to threaten our friend homeostasis. So it's going to get to the point where everything's off kilter. So stress can continue that you cannot maintain your happy, stable, normal internal environment, and it messes with that. And so it can have an impact in many different systems of the body. So with stress, you both have hormonal responses and you can have other physiological responses because of the hormones. So we call this the stress response, and we can also call it the general adaptation syndrome. There's two different types of stress that we use. We use eustress, which is actually helpful. We like being stressed out, at least in some sense, because it helps motivate us and move. And so a little bit of stress can be a good amount. stress is bad stress. So it actually gets to the point where it's harmful to our body. So we have 3 stages to our stress response. The initial fight or flight. So you imagine this is going to have to do with your sympathetic nervous system. So you're going to see epinephrine is going to be a major one, norepi too. Then we have slower resistant reaction, which is going to be more cortisol is going to come into play. Glucocorticoid. Eventually, we just give up. So exhaustion. Can't do anything. You've done everything you can to deal with this stress response. You just can't do anymore. So continued response to cortisol can cause wasting of muscle, so decrease in muscle mass. Remember all the things that you're talking about with cortisol. You're going to have high blood glucose consistently. Your muscles are going to waste. You are anti-inflammatory. You suppress your immune system for a long time, so you're getting sick. You actually destroy the linings of your GI tract, so you cause ulcers. And eventually, because of the continuous high blood sugar, blood glucose, you're going to stop your pancreatic beta cells. Beta cells make insulin. Insulin is trying to decrease your blood glucose, get it back to normal. So first phase is your alarm phase, which is the initial fight or flight. Again, that's the sympathetic. That's the immediate response. All of a sudden, you're scared. Or you have test anxiety. You got a test or something. So it's the initial response. Epinephrine is going to be the major one. You have norepi too. So it's the dominant hormone. So everything that we saw with epinephrine, so you're going to use your energy, you're going to increase your blood glucose, you're going to divert all your blood to your brain and your heart, you're going to increase your heart rate, you're going to start to sweat, you're going to increase your respiratory rate. All of those things that we see with the release of epinephrine is going to happen here because that's the dominant hormone. The next phase we can consider is the resistance phase, which is going to be more cortisol. So this is, you've been stressed and you've been using epinephrine for a while, but now cortisol is going to come into play. And it's the major glucocorticoid. And that's the dominant hormone of this phase. You still have a little bit of growth hormone, thyroid, because you're increasing your metabolism. So you're trying to get your cells ready to go. Epinephrine still involved, but the dominant one is your glucocorticoids. Because of the continuous stress, then you still have that continued high energy demands. Eventually, remember glycogen, glucose storage molecule, it's going to be broken down until you got nothing left. Use up all your stores, nothing. So then, once you have used up all your stores in your muscle and your liver, and you can't release glucose that way anymore, you're going to start breaking down your fat and you're going to start breaking down the proteins. And so that's when we talked about muscle wasting eventually, is because what is a whole host of muscles? A whole big amount of protein that you can break down. So you're going to start breaking your fat down. Again, you can make glucose out of lipids. And you're going to break down your proteins because you can make glucose out of lipids. Again, you're going to keep your blood glucose high because one place that you can never stop the uptake and it's not dependent on insulin is your nervous system. So your brain. So your brain is going to maintain the blood glucose and it's going to use it up. But there's only so much your brain can use. You're going to continue having blood glucose high, and it's saved for your nervous system. last phase, so you've been releasing glucocorticoids for a very long time, and eventually you're just exhausted. Your body gives up. So this is really when homeostasis is going to come to a complete breakdown. You can't maintain your minerals or your electrolytes, and eventually your organs are going to start to fail because you just can't maintain this anymore. You've used up all of your fat, you've used up all of your muscles, you have no more energy, so you can't maintain your blood glucose anymore. You get infection because you can't have an immune response. Um, you're consistently trying to keep a high blood pressure, which can be damaging. So all of these effects eventually where just can't continue, can't be maintained, and you get to the exhaustion phase.